Hello everyone, my name is Gaurav Seth and I am a product manager on Azure App Service team, and today I'm going to talk about how to add generative AI capabilities to your .NET web apps for Azure App Service. So before we get started, here is a quick view into the agenda for next 30 odd minutes. So I'm going to talk about some of the key app service benefits, AI-assisted migration and modernization. How do we integrate Gen AI capabilities for a classic framework .NET web app? I'm going to talk briefly about intelligent observability and how do I integrate Gen AI capabilities again for a net new .NET web app using .NET 8. So let's start by talking about some of the app service benefits. Now, there are multiple benefits of deploying your web apps on app service, but today I am focusing primarily on the ones that are specifically useful for apps that use generative AI capabilities. Now, first thing is you focus on integrating Gen AI capabilities with your web app and not on the underlying infrastructure. Now, we also know that with the speed of AI innovations, you may need to release newer versions of your app faster and easier, and that's where native CI/CD integrations with popular services like GitHub, Azure DevOps, etc., makes it super easy and fast for you to go ahead and release newer version of your web apps. Now, it is also important to understand that while you may scale your AI backend or any other backend services that your web app is talking to, you would also require to scale your web app to address sudden burst in traffic, and that is where the platform allows you to scale either manually, or you could do an automatic scaling, or you can also do a rule-based scaling wherein you can use stuff like scheduler, or you can even use a certain metric that you want to scale your web app. Now, remember, App Service supports most of the popular languages and frameworks irrespective of Windows or Linux operating system. So again, you have all the support required to deploy your web app to Azure App Service. Now, we all agree that security is critical for your web apps. You can build a security first posture for your web app using features like virtual networking, managed identity based authentication. Microsoft Defender integration becomes super important for your web app, and these features are available for you when you deploy your web application to Azure App Service. Now again, if you want to use advanced concepts like vector caching for your Gen AI web apps or utilize AI-powered monitoring auditing solutions from some of our Microsoft partners, we have recently introduced a sidecar feature for Azure App Service Linux, which again becomes very important. And even remember, this is all about how do you integrate Gen AI capabilities for your web app. Even for Azure App Service as a platform, we have started utilizing the power of Azure Copilot to help you diagnose and troubleshoot your web app. Now, let's briefly talk about some of the demo scenarios that I'm going to talk about. So, you have a .NET Web App on-prem that you plan to migrate to App Service and also infuse generative AI capabilities into your web app. Now, I will show you how to use AI-assisted tooling in Visual Studio to analyze your source code and then use free tooling to migrate your web application to Azure App Service. I will finally showcase how to introduce generative AI capabilities for your existing .NET Framework web app without the need to redesign or redevelop your complete web application. Now, before I get into talking about the first scenario, I again would want to reiterate the other scenario as well. So while I said that I'm going to talk about how to introduce generative AI capabilities for your web application, which is based on ASP.NET framework, I am also going to talk about how to introduce generative AI capabilities when you are building a net new application, for example, using .NET 8. So these are the two core scenarios that I am pretty much going to focus this entire discussion on. So let's get started with AI-assisted migration and modernization, and then also how to introduce generative AI capabilities for a classic .NET web app. With that, let me switch over to Visual Studio. Okay, so this is a sample web application that I have here, and what I'm going to do is that I am actually going to use the Visual Studio Marketplace extension called as Azure Migrate Code and Assessment Toolkit, which basically does a source code analysis, and also if you have the GitHub Copilot chat integration with your Visual Studio, again, it also makes you suggestions and recommendations of code changes that may be required. So how you do that is you go ahead and download the extension from Visual Studio Marketplace, install it, and once that's done, you basically click on this new option that you start seeing called as Re-Platform to Azure. Now, you're presented with two options. Either you can start on a new report, or you can also open an existing report. So I'm going to start by clicking on a new report. Now, it lets you select the target that you would want to deploy your code on. So in my case, I'm going to choose Azure App Service Windows. I'll click Next. Now, because I have two projects, it gives me option either to select both or one. Maybe for the sake of simplicity, I just select first project. I click on Next. Now, in addition to the source code and settings, I can also make a selection about binary dependencies. I'll go ahead and hit Analyze. Now, within a matter of seconds, I'll be given this nice looking dashboard, which gives me a summary of severity, categories, etc. Now, let's go ahead and look at different issues that's been reported. So as you can see that I have first issue being reported, and again, you can see the severity being reported is potential, optional. There's yet another severity called as mandatory. Now, take for example, if your web application was to use integrated authentication on-prem. Now, when you move your web application over to Azure App Service, you can still use authentication, but that would more be based on Entra ID and not the integrated authentication that you use on-prem. Such kind of issues are reported as mandatory. So let's look at a potential issue. So we have this issue being reported that my web application is probably trying to access some external resources, and I get which DLLs are doing that. And then if you see, I have this option called as Ask Copilot. Once I click on that, what's going to happen is, let me zoom into this window. So what's going to happen is it will pick up this specific warning or error and try and give you helpful context. Now, using this context, it describes the issue and it even provides you the steps to resolve this issue. So it talks about maybe you can update ports, you can migrate internal services if the access is for an internal service, and this is how you would do that. So this is basically your example code adjustment that you may use if you want. Now, what you just saw is how the power of AI can make it simple for you to fix source code so that you have a higher degree of success once you migrate your web application over to Azure App Service. Now, for a moment, let's switch back to our slides. And before I move any further into the actual demo, I also wanted to quickly talk about that, like you saw the source code analysis, which is AI assisted, of course. You also have a bunch of free tools that you can use. So imagine a scenario. Once you have the source code analysis, you have fixed all what's required. Now the idea is to migrate your web application, and App Service team basically provides you a bunch of free application tooling, which could be the whole Azure Migrate integrated experience or simple PowerShell scripts. Now, depending on the use case that you have, which could again be a data center exit or a single IS web server migration, you could make a choice of your tools. Now, broadly, what each of these tools does is it runs a discovery. So if you're talking about the whole integrated Azure Migrate experience, we do a bulk discovery where we go ahead and based on your virtual appliance, that is a one-time configuration, we pick up all the servers which are running IS Web Server, and we give you a rich inventory of all the .NET Web applications. Once the discovery is done, you go ahead and run assessments. Now, what assessments does is based on attributes like what region you plan to migrate, are there any discounts or pricing, tiers that you wish to use, or are you going to migrate to an app service environment if your requirement is around an isolated deployment. We would basically go ahead and run a bunch of configuration checks and come back and give you a report in terms of what's ready to move with conditions, and what's not ready to move. Now, when I say what's ready to move with condition, the idea is that your web application will move fine. It will migrate just fine. But the challenge is that once your web application is migrated, you may need to make some configurational adjustments or changes. For the best example I can give you is your web application is hosted on a non-default port on-prem like 9000. But once you move it to Azure App Service, the only traffic is available over port 80 and 443. So that's the kind of changes that I'm talking about. Now, once you're done with the discovery and the assessment, the whole Azure Migrate experience also allows you to do a bulk migration of the selected web applications over to Azure App Service. So what we do is we move the whole zipped content and the configurations for a web application, and for every individual web application that's on a IS server, we create a net new Azure web app and then deploy your code and config over. Similarly, if your requirement is not an entire data center exit, if you just want to move a bunch of web applications out of a single IS web server, you can use PowerShell scripts. Technically, behind the scene, PowerShell scripts also do exactly the same thing. We discover, we let you assess, and then we migrate a web application. But I just want to give you a quick shout out to two more scenarios that PowerShell scripts become super helpful. One, if you are trying to move your cloud service. So if you still have like a web role on a cloud service, you can actually use PowerShell scripts to migrate them over to Azure App Service. Or if you have a hybrid or like an offline online scenario where you could run discovery and assessment on a server which has no internet access, and then move the zip over to a virtual machine which has internet access, and then finally migrate your web application. With that, let me quickly move over to the sample app topology or the demo app topology that I'm going to showcase next. So now this is a sample topology for a first demo app. Now we use, as I already showcased, we used Visual Studio Application Code Assessment Toolkit to analyze an existing ASP.NET web app on-prem, and then we made required code changes if they were needed. Then, as I spoke about the number of tools that are available, I migrated this web application using PowerShell scripts. Now, here is the interesting point. You can either decide to introduce Gen AI capabilities before you migrate your web application over to Azure App Service, or you can redeploy your code once you made the changes after deployment. So that's completely up to you. And just a quick call out that for the demo, we are using GPT 3.5 Turbo. Now, the other important point to understand is that that the demo, web app, and all the required resources are deployed to a landing zone. Now, a landing zone is basically a sort of a templated deployment for you, which is based on architectural best practices and, of course, adheres to all of the goodness that comes with Azure around security, scaling, isolation. Now, also, it is important to note that all communications between app and other Azure web services or other Azure services for that matter are secured using virtual network and managed identity authentication. With that, let me move back and showcase. So this is basically the web application that I was talking about. So in the interest of time, I've already migrated this web application from an on-prem IS web server over to Azure App Service. And as you can see, now once you've migrated a web application, remember, as a platform, we provide you a bunch of features that you can use. It could be around you want to do scaling, or you want to look at your environment variables, change them. If you want to set up authentication, set up application insights for basically observability, scale up, scale out a web application. So yeah, there are a lot of things that you can do from the platform itself. Now, this is the demo web application that I was talking about that I migrated. This is like a hypothetical dev shop where we are selling a bunch of products. Now, if I go ahead and basically get into one of these, let me go ahead and get into any of these products. What I've done is, here is the example scenario. This was a ASP.NET, or this still is a ASP.NET framework web application that I migrated. And what I've done is, to this existing web application, I've introduced this new capability called a chat with AI assistant. Now, what's happening behind the scene is I have done an integration using the Azure OpenAI .NET Client SDK, and using that integration, basically now I can go ahead and let my customers use the power of Azure OpenAI to ask questions and get relevant answers. So maybe, I can get answers. And just to quickly point out, in this specific demo, I am not using the concepts like RAG, or I'm not using the database context for my search. I'm just going to make a search directly against the Azure OpenAI endpoint. So maybe I can just ask any question. Suggest a travel bag $100 maybe for students. And that's how I get the response back. Now remember, what I am trying to showcase is a very simple but yet super powerful scenario where you have an existing web application, you have modernized it using the Visual Studio extension, you have gone ahead and then migrated the web application, and now what you have done is you have infused Gen AI capabilities for an existing web application. I have not redesigned or redeveloped the entire web application. What I've simply done is I've gone ahead and introduced this additional capability. So that's the scenario that I was talking about, where you can introduce intelligent capabilities for an existing .NET or .NET framework web application. Now, if I go ahead and show you the code changes that I made, so that's basically my web application. So what you saw where I was like having the chat experience was the chatbot.aspx page. I'm using a very simple jQuery call to my chat controller, and that's my chat controller that I was talking about. As you can see here, what I did is I've developed a new chat controller, and what I'm doing here is I'm using the the NuGet packages for Azure OpenAI Client SDK for .NET, and the Azure Identity SDK. Now, what I'm doing here is I have defined all the configurations as parameters so that I can define them as settings in my app service. I create the OpenAI client. And the most important point that I want to highlight here is, as you can see, that the entire communication between my web application and the Azure OpenAI backend is authenticated using managed identity credentials, and that's exactly what I'm doing here. Now, once I've established the connectivity, I use the get response message. And in this method, what I'm doing is I'm using the chat completions API. Now, in this API, I pass the model, and then I use a prompt template. And what I've done for my prompt template is I'm saying that you are an employee of a store that provides product recommendations based on user query. And again, I want the recommendation to be upbeat and friendly and just a single recommendation. So once I've done that, I pass the message and I pass the user query, I get the response back and send it over to the page. So if you see, it's just a few lines of code, but now what's happening is my existing web application has generative AI capabilities. With that, I'm going to move back to my slides. Now let's move on to the next piece. So I just spoke about existing web applications. Now let's talk about what if I want to create a net new .NET 8 web application. How do I introduce generative AI capabilities? So again, there are a number of ways that you can do it. You can either do a simplest of approaches using REST APIs. You can use Azure OpenAI SDKs. Recently, we have also announced OpenAI SDK, which is currently in beta for .NET, and it works with GPT-4o. Or if you have requirements, you can even use higher level LLM frameworks, something like LangChain or semantic kernel. Remember, and if you want to look at some of the samples, you can go on the link on your screen. But that's some of the ways that you could introduce generative AI capabilities into a new .NET 8 web application. And again, here is a quick summary of how do you go about adding these capabilities to a .NET web application. I already spoke about how to add generative AI capabilities using SDK for an existing web application. You can also do the same way for a new web application. You can use semantic kernel. And now the reason behind using a semantic kernel is if you have a scenario where you want to orchestrate across multiple different models. I mean, that's a demo that I'm going to show in a while. Or if you're trying to look at using a sidecar pattern on Azure App Service for Linux, especially if you are looking at options like vector caching to improve performance and even lower cost. I mean, these are different scenarios or ways that you could be introducing generative AI capability for a new .NET 8 web application. Again, here is a quick view into the topology before I go ahead and showcase the code and the web application. Now, this is a .NET web app. I'm introducing Gen AI features using the .NET SDK for OpenAI. Now, this web application also uses the sidecar feature for App Service Linux because I wanted to use vector caching so that I can reduce round trips to Azure OpenAI endpoint. Now, we are also going to make use of semantic kernel for overall orchestration of app, DB, and OpenAI communications, and also use text embedding model and GPT 3.5 Turbo. Now, again, remember, it's the same concept for deployment. All the required resources get deployed to a landing zone for security and best practices perspective. And also all communications are again secured using virtual network and managed identity based authentication. And before I switch to code and demo, I also want to quickly talk about intelligent observability. If you remember, I did say that one, if you have a requirement where you want to use the sidecar feature for bringing in some of our partner offerings, which could again be AI assisted for logging and auditing. So you could use the sidecar feature for that. Also, I'm going to in my next demo, I'm also going to talk about Azure Copilot. So yeah, that's where the whole concept of intelligent observability comes into the picture. So I'll showcase how you can use Azure Copilot to simplify your whole diagnose and solve app performance or app errors. With that, again, I'm going to switch back to Visual Studio. And before that, here is the .NET 8 app web application that I was talking about. Remember, this is exactly the same web application that we just saw for framework. Now maybe I can just get into jewelry or accessories. Maybe I'll just go ahead and navigate to jewelry. And if you see exactly the same concept, I can say chat with AI assistant. Now, the quick difference here is that every time I am going to post a query, what I'm also going to do is I am behind the scene, I am also using the whole Azure OpenAI search with my Azure SQL database. So I'm basically going to use the capability of AI search on my database, get the context, and then use Azure OpenAI to summarize and give the response back to you. So if I say, suggest gold-plated chains, if you see the first time, the response is going to be a bit slow. The reason is this response wasn't there in my cache. Now, next time, if I go ahead and ask a similar question, or if I go ahead and ask a question which is again similar in context, I would basically get a much faster response from the cache that I'm using. You can see how fast we get the response back. And let me go back to the code now. So this is basically the same controller that I created, but this time it is for .NET 8. Now over here, what I've done is, one, remember, I am using session history over here. And secondly, after I'm done with all of this, and yes, just a quick call out before I move on, I am using the quadrant for my vector caching. I'm using quadrant database for my vector caching. And this is where basically the whole get response method comes into the picture, which is used for getting the query from the user, doing all the basically communication back and forth with the OpenAI endpoint and then sending the response over. So you can see here that I actually have a quadrant endpoint in which is localhost. Now the interesting thing here is, from my web application perspective, I am using sidecar pattern. And once I do a sidecar pattern for my web application, the whole quadrant database is available as a local host endpoint. And that's why if you see, I'm actually using a local host endpoint. Once I have defined the endpoint, I go ahead and create a cache using the quadrant database. And then this is where I am getting into using the semantic kernel. You can see here that I create the deployment name And remember, as I said, the entire conversation or the entire communication between this web application and the OpenAI endpoint is secured using managed identity credentials. Now, for generating this text embedding to use with my OpenAI search for on my SQL database, I'm actually using the text embedding model. Once I do that, once I generate basically these tokens, what I do is similarly, like I showed in my previous demo, I create a prompt template just to instruct what kind of personality I'm looking for in terms of my responses. And I also add this context to my session key. Once I'm done with these things, I go ahead and serialize the history. And finally, you can see here, that's where I start the actual chat functionality. So what I do here is, I'm using the chat format for semantic kernel. I pass in, and as you saw that we also keep we also maintain the chat history. So that's how we do it. And once I get the tokenized form for the user query, I send that to be summarized using Azure OpenAI endpoint, and that's basically the model that I'm using. And then I go ahead and stream the response back to my end user. So again, what you have seen is I can either do a simple integration with an existing web application, or we also support, or we also let you deploy your web applications if you're looking at more advanced concepts around vector caching for your web applications once you start using the sidecar pattern. With that, I'm going to switch back to my okay, and let me also quickly talk about the whole Azure Copilot experience. Now, once you click on Azure Copilot, now imagine I am experiencing some kind of slowness on my web application, and I want to use the Copilot capabilities to help me diagnose and troubleshoot the whole slowness. So what I'm going to do here is I'm going to say web app slow. Once I type this, now Copilot would automatically get the context of this specific web application, as you can see here, and then it is actually going to suggest you so behind the scene what's happening is this is actually using the inbuilt intelligence to go ahead and diagnose using some of the detectors that we have, and it's going to come back with a bunch of solutions that you can use. So you can see here some of the potential root causes why your web application could be slow. So it could be like, if your CPU consumption is beyond 70%. And then once you know some of these root causes, what are the solutions? So you can collect a profiling trace. Now, I can go ahead and keep conversing with Copilot. I can say, okay, now tell me how do I collect the profiler trace? So I can do that. But the idea here is that, again, we are using the power of Azure Copilot to help you diagnose and troubleshoot your web application. So what are the key takeaways from this session today? So we talked about how do I modernize and migrate my existing .NET web application over to Azure App Service and infuse generative AI capabilities, and also how do I introduce generative AI capability for a .NET, for a net new .NET 8 web application. So we saw both the scenarios where I have an existing web application or I am trying to add generative AI capabilities for a new web application. Now, if you want to get started with Azure App Service, here is a list of useful links that you can use. Now, we are on Twitter. We also have a lot of blog articles that you can go through. So, with that, I conclude this session. Thank you for joining in and have a great rest of your .NET Conf focus on AI.